Guys. Pretty crazy weather yesterday in parts of the Mid-Atlantic, even here in Pennsylvania, up in the Northeast, even to Boston last night. And looks like a pretty quiet weekend, but I'll let Mike Dahl here from AccuWeather talk about it.
Thanks, everyone, for coming. My name is Mike Dahl. Just a brief background about myself. I'm a 1997 graduate of Purdue University. First job I had was in Wichita, Kansas. I was there for 8 years working for Weather Data, which later became part of AccuWeather, so I've sort of come full circle. Then I worked in a smaller private company outside of Chicago, and found my way here in June of 2013. So I've been here a little over 2.5 years. I thought what we would talk about today is talk a little bit about the Midwest snowstorm, sort of show an example of why snow forecasting is so difficult, and then talk about the severe weather outbreak in the Mid-Atlantic from yesterday, and talk a little bit about the upcoming weather over the next couple days across our area. But the Midwest snowstorm was interesting because the heavy snow impacted the an area where I grew up in the extreme northwest part of Indiana, not too far from Chicago. So this image was from the graphic the National Weather Service in Chicago put out, showing how there was very little accumulation in Chicago, but in Cedar Lake, Indiana, they had 12 to 15 inches of snow, difference of 34 miles. The Pocara's output here, trying to get this in the slideshow for some reason, not letting me go into it, but anyway, hope everyone can see. But basically, Cook County to Chicago, they only had an inch or two of snow, but you go down across Cook County into west or eastern Will County, and they had well over half a foot, and then Lake County, Indiana, some places had over a foot, up to 15 inches in Porter County. Illustrates the difficulty of forecasting snow. The difference of storm track of 10 to 20 miles farther west, you're looking at a major impact to Chicago. Whereas in this situation, did not have that great of an impact on a city with several million people. One thing is operational meteorologists that, especially when you're dealing with clients in snow and ice management municipalities, several things you have to take into consideration, especially in a situation like yesterday where it was somewhat borderline. Recent days it's been rather warm in Chicago. After the cold snap from earlier this month, it gave the ground temperatures a chance to warm up, and snow falling during the day, when you're forecasting for a municipality like the city of Chicago, trying to determine how much snow is going to accumulate on pavement, because that's what they care about. They don't care about what's going to fall on a grassy surface, because as they will tell us, we don't plow on grass. Well, obviously. So that poses a challenge in these borderline situations where a forecast that you may see on AccuWeather.com for Chicago could be different than what you might be telling clients who only care about how much snow is going to accumulate on pavement. So in the case yesterday, what we were telling the city of Chicago was, you're not likely to see much accumulating on pavement. You're going to see a lot of melting. And I found a website that was able to find the actual pavement temperature from a location in the southeast part of the city. And this is in local time, not Z time. So this is starting at 8:30 yesterday morning, going through 4 p.m. in the afternoon. This column here is the air temperature. This column here is the actual temperature of the pavement. So as you can see in the morning, pavement temperatures were above what the air temperature was. And you can tell when the precipitation started, not only because the surface state went from dry to moist to wet, and as it started snowing a little bit harder, here you can see, notice the air temperature gets down from 33 down to 32, actually below freezing. So what happens to the pavement temperature? It's also falling toward freezing and even below freezing. And notice the surface state goes from wet to slushy. Well, what happened when there was a let up in the intensity of the snow? Notice the air temperature started coming up, 32, 32 and a half. And notice the pavement temperature started warming to above freezing. Keep in mind, though, it's still snowing in this period, but in all likelihood, it's melting on contact. Now, the city was probably spreading salt, which that had an effect. And salt is really effective at temperatures like this. It's just going to eat up whatever snow is falling, making contact with the pavement. So, when dealing with a municipality who wants to know how much snow is going to accumulate on pavement, this is the kind of information that's very valuable to determine what the surface state is going to be and how much accumulation can they possibly see on the paved surface. So what was sort of the driver and it caused the heavy snow band to fall short of reaching the Chicago area and impact areas south of the city and into northwest Indiana. I'll talk a little bit dynamics here. I know you guys are in class and you're hearing about dynamics, so I'm going to try and take it easy on you. But you've probably seen this graphic here on the right, and I'm sure you've seen it in your textbooks, sort of a cross-section of the entrance region of the jet, and how you get a direct thermal circulation, so where you have upward motion on the right entrance region. Well, with frontogenetic circulations, you also get a circulation. So on the warm side of an area of frontogenesis, you have upward motion. On the cold side, you actually have sinking motion. So from the SPC mesoanalysis, and I hope this is going to, for some reason it's not, well, this is supposed to be an animated GIF, but.
Maybe that little bar down below, if you hide that, Google Hangs. And maybe not.
Yeah. But, but anyway, so I'll just kind of use the pointer here. The area of 700 millibar frontogenesis basically stayed stationary over Chicago. So the warm side of it, your highest, your strongest upward motion was across the northwest part of Indiana. So this stayed in this state for through the morning hours and into the afternoon. Eventually started getting heavy snow up in Michigan. So as a result of that, That's why you had your heaviest snow falling in northwest Indiana, where they had anywhere from 12 to 15 inches of snow. So again, this illustrates the difficulty as meteorologists trying to predict where the heaviest snow is going to fall. And in this situation, given the track of the 700 millibar low, the surface low, was a little bit too far to the south and east to put Chicago, the city itself, into the heaviest snow. I think the surface low pretty much tracked across southern Indiana. For Chicago, a good track is over or even just a little bit north of Indianapolis. The blizzard of 2011, surface low track just to the north of Indianapolis, and you know, they ended up with 20 plus inches of snow. That was the first true blizzard, I guess, that I had ever experienced, and I was living there at the time, and was at work, and I could not. I lived 45 minutes away. I could not get into my subdivision, so I had to spend 2.5 days at the office. I slept on an inflatable mattress in my office. I had one change of clothes, and when they finally got around to plowing our streets where I could get home, that was one of the happiest people on the face of the earth. So blizzards are cool, but when you're you know, when you're working and you have a family, it does create a lot of inconvenience, but still, it was a pretty amazing thing to experience. So next, I'll kind of go over the severe weather outbreak, which, looking at the soundings here and the parameters, were really impressive. These would be impressive at any time during the year, but when you're looking at a climatologically unfavorable time of year for severe weather in the mid-Atlantic, makes it even more impressive. And the day started out pretty, pretty benign. I mean, this is the Greensboro sounding from 12Z. Obviously, they're north of the warm front because there's obviously a sharp low-level inversion. A lot of elevated instability, certainly, and certainly have quite a bit of directional and speed shear. Already have more than 50 knots at 850 millibars, really good turning with height. At IAD, a similar situation, obviously farther north, strong inversion, some elevated instability, not as much as what was going on in Greensboro. MHX, now they're in the warm sector at this point. This is 12Z observed, and already pretty unstable, very unstable for February 24th at 7 o'clock in the morning, with Moo Cape of 1100, surface Cape also over 1,000. Pretty impressive for this time of year. Obviously, if this was a sound, we were looking at a sounding like this in June, wouldn't think much of it, but for this time of year, different story. APG, again, they're in the cold sector, low-level northeast, east-northeast wind, and not so much elevated instability at this point. Now they did launch a balloon every 3 hours, I think, at Greensboro, East 12, 15, and 18Z. So not much difference 3 hours later in Greensboro. They're still in the cold sector, still have a low level east wind, still have some turning in the lower levels. Pretty impressive surface to 1 kilometer shear. I believe that's 62 knots. That's more than enough low-level shear for tornadoes to form. So already the environment is already conducive. It just you got to get them into the warm sector, which eventually they do. And then here's Greensboro 3 hours later. The warm front has surged northward. I'll just kind of go back and forth. You can see the difference. What the profile looks like 3 hours later. Now at 18Z, still have quite a bit of, especially speed shear in the low levels. Cape is Moo Cape 1700, and notice your significant tornado parameter in the fixed layer is now 2.9, which is really high. I mean, generally anything over 1 is ideal if you're looking for the potential for a strong tornado. 18Z sounding at IAD again. It takes a little while for them to get the warm sector, but eventually they did, and they also had their fair share of severe weather when their although mainly their form was damaging winds. MHX 18Z, very unstable environment, really good shear in the low levels, directional and speed shear, surface to 1 kilometer is over 50 knots. And notice their significant tornado parameter is around 2, which is more than what you would need to get a strong tornado. And there's MHX at 0Z. I think at this time that the storms were still off to their west. Look at the significant tornado parameter, 5.8. Not often you see an STP value that high. And if you look over here on the bottom right-hand side, these are staggeringly high probabilities. Might be hard to read, but the probability here on the bottom of an EF2 or stronger tornado is based on the STP is 32%, which is extraordinarily high. 300 millibars. This is midday 18Z. Here's the nose of a 120 knot jet at 300 millibars approaching the Carolinas. Already have really, really strong diffluence aloft, it's just a matter of getting the atmosphere to become unstable as the warm front pushes north, and you already have really, really strong dynamics to get thunderstorms to develop. Here's taking sort of a larger scale of the STP parameter. Anywhere the solid orange, that's 1. It's basically every 1, so 1, 2, 3, 4. Basically bullseye across central and southern North Carolina. This is 1 hour or 2 hours later. It was about this time, because Richmond would be about here. It was about this time that unfortunately there were I think 3 fatalities in Waverly, Virginia, which is to the southeast of Richmond, was tracking across this area. And what I've found is that in tornado outbreaks, you don't necessarily need to be looking where the bullseye is. Usually, you're going to find your tornadoes somewhere on the periphery. It's kind of with the photogenesis map I showed earlier, where you don't want to necessarily look right in the middle for your heavy band. It's usually going to be on the warm side. I've seen instances the November 17th, 2013 outbreak in the Midwest, where your violent tornadoes didn't occur where your bullseyes of STP were. They're actually on the outer perimeter. So if you're looking in this area, thinking, oh, this is where the best chance of tornadoes is going to be based on significant tornado parameter. Other factors, obviously, being conducive for tornadic supercells, not necessarily looking in the right place. Usually, it's going to be somewhere on the perimeter. And you can see the starting to get into the 0.5, pretty close to DC. I don't think there were any tornadoes in Maryland, if I recall. I think they were all in Virginia, North Carolina. I don't know if there was. Were there any? Does anyone know if there were any confirmed tornadoes on the Delmarva? I think there were. But using this, from the meso-analysis from SPC, they have a ton of really, really good tools. Can certainly give you an idea of where to look for where the potential is there. Anyone have any questions about the winter storm, severe weather outbreak? It was nice to hear some thunder around here. Kind of missed that. But what we talk about now is, I guess, kind of go over sort of what's happening now in our part of the country. Talk about the weather over the next couple of days, although we've obviously cooled down quite a bit, but it looks like we'll be pushing 60 degrees by Sunday. So kind of looking at the surface map across the northeast and New England. Obviously, the cold fronts push through us, very mild across New England. Even got some 60s in southern New Hampshire, darn near 60 in Concord, and even Atlantic Canada. How often do you get a thunderstorm in Nova Scotia in February? 1 mile plus TSRA. So obviously, when you have unusual conditions, you're going to get unusual weather. But and with the upper low that's spinning across the eastern Great Lakes, and all the cold air that's wrapping around, getting a lot of snow shower activity across Ohio, western Pennsylvania, and Michigan. Obviously, with a westerly flow, as is typical, we're getting the blade effect, and we're just sort of, I'm going to use the word, Tyler, and we're getting the dregs of everything. But it looks like with this pattern, this is a pretty good setup that the Appalachians and into the Laurels should do pretty well over the next 24 hours. The Elkins reporting S plus, and I suspect with all the moisture upsloping along the spine of the Appalachians that we're probably going to see several inches of snow across West Virginia and into southwest PA. Wouldn't be surprised that to see something on the order of 4, 5, 6 inches through tonight. So taking a look at the radar, there's the upper low kind of spinning just near Buffalo, and looks like there is a vortex that's moving through. It's a subtle one, but enough that's picking up moisture off of Lake Erie, and getting some decent returns and some decent snows across northern Ohio. This is not a very cold air mass, and since we had the recent cold spell, the lake water temperatures have cooled, so we don't have a huge difference from lake surface up to 850. So this is not really a good lake effect setup, but more that with any type of PVA over the lakes, you get more of lake enhancement. You can see all the snow showers across western PA, and so we're starting to get some enhancement on the other side or south of us. All that we've had so far is it's been a couple rain snow showers, nothing to get too excited about. But obviously, anytime you have a west-northwest flow, on occasion some of these heavier snow showers do make it up and over the mountains, and I guess around here I suspect that probably wake up tomorrow morning and find at least a light cover on everything. Certainly to the west of us, Du Bois, I could see them getting a few inches of snow, but again, down in the Laurels, I think 3 to 6 inches is probably a pretty good bet. But as far as what the latest progs are showing, with the latest the 12Z GFS, there's our eastern trough. Not a whole lot of strong blocking in place, so things are fairly progressive. And in fact, you see the strong ridge out in the western U.S. Kind of have one final piece with this trough to move through, and then pretty much we go into a zonal flow over the weekend. And so this brief cold snap will be very brief, and like I said, Sunday we're probably going to be pushing 60 degrees with a nice southwest low-level flow. Obviously no snow on the ground, so be pretty similar to what we experienced about a week ago when we got into the 60s. So Sunday looks pretty nice around here. And you can see late in the day, be a bit breezy, but otherwise pretty decent. and this short wave moves through, but again, doesn't deliver any cold airs. It's all bottled up into in Canada. Again, our air mass is going to be Pacific in origin, so looking at a much milder pattern coming up. Nothing that's going to remind us of late spring or anything like that. But start getting really in a big difference between the GFS and the European. Getting out to early next week. We have this system that digs across the Rockies, whereas the GFS doesn't dig it so much, and pretty much tracks it right across the plains in Midwest. If this was right, or this is right, it could be a pretty good snow event for the upper Midwest. But again, regardless of the frogs, we're still looking at a pretty mild pattern. And if either one of these systems, regardless of the track it takes, it's obviously going to be a rain event and not snow. Of course, if this is right, it could be dealing with another squall line in the later part of next week across the eastern United States. But really, at this point, there are no indications of any intrusions of Arctic air. Certainly no significant snow events across our area or anywhere in the Mid-Atlantic. I haven't had a chance to look at anything longer range. Looking toward the middle of the month, at least not over the past couple of days. But even the European weeklies that came out on Monday really aren't showing a gradual breakdown of this western U.S. ridge. I mean, we've been in a positive P&A pattern pretty much the entire winter. This ridge, some indications this ridge will break down, and our flow becomes more or less zonal toward the middle part of March. So, for the snow lovers, I don't have good news for you. And if you're like me and you like spring, yeah, we have something to look forward to. Anyone have any questions on that or anything else?
More questions? Okay, thank you very much.
Well, thank you.
Next week will be Dr. Heath.